In the diagram above, AB represents a uniform rod of length 90 meters, which has a load at 15 meters from one of its ends. If the pivot is at its center of gravity, what force must be applied at its other end to keep it in horizontal equilibrium? So there's something we call moment of force. Moment of force. What does it do? Moment of force brings about a turning effect of an object. For instance, in a seesaw now, if one person sits on a seesaw now, this seesaw is likely to turn like this. So that means that person now is bringing about a moment of a force in that seesaw. It's causing the seesaw to turn. The same way, if another person sits down here, it causes it to turn like this. So moment of force, any action that causes an object to turn, moment of force. Now, if these two moments are equal, definitely this seesaw will not turn. So when it's in equilibrium, that means this moment should be equal to this moment, so that you counterbalance each other. So that's it. Clockwise moment must be equal to what? Anti-clockwise moment. For something to be in equilibrium, that the two turning effects has to be equal. Okay, now so let's look at this thing now. They say what force must be applied at the other end. So let's go to this other end now and apply a force now. Now, first of all, they say that this is at the center of its gravity, and the length of this rod is 90 meters. So at the center, if this is 90 meters, the center will be what? 45. This is at the center of the gravity. So, and every force that's causing moment has to be done with respect to the pivot. So if here to here is what? 15, and the whole thing is 90. So if you subtract 15 from 90, that means here is what? 75. Sorry, here is 45. You remove 45 from 15. That means here is what? 30. Okay, so at the other end now, here is what? 45. So we are done. So let's say the force is F. So that means this 30 Newton will apply an action to this distance, while this F will apply an action to this 45. So that's it. So 30 times 30 will be equal to 45 times F if it has to be in equilibrium. So let's do it now. So the F1 times what? D1 is equal to F2 times what? D2. So you got as 30 times 30 is equal to F2 times what? 45. So to get F2, we divide both sides by what? 45. So 30 times 30 divided by what? 45. So the force that must be applied at the other end is what? 20 Newton. That's the answer. Thank you.